Alright, in this video I'm going to be talking about double displacement reactions. In a double displacement reaction, the cation and the anion for one atom switch with the cation and anion for another molecule. So the metal from one goes with the non-metal from the other, and then the other non-metal and the other metal are left together. So here we can see the general reaction AB, so the A and CD, so the A goes with the D from the other atom, and the B goes with the C, so CB. So basically they switch their partners. In a reaction like Na2CO3 and plus CuCl, we can see that the sodium and the copper can effectively change positions. So I'm going to get NaCl, see, that guy goes with that guy now, plus Cu, and careful here, this was copper 1, right? If I imagine the reverse crossover. So copper 1 plus CO3, so it's going to be Cu2CO3 like that. Now to balance here, I would have to put a 2 here and a 2 here, and then we'd be all balanced up. Get rid of that. So see, the sodium went with the chlorine and the copper went with the carbonate. They've switched partners. A secondary example of a double displacement reaction. Here, iron nitrate and calcium chloride. So the iron's going to take the calcium's place. So keep careful here, that was iron 3. Oh, sorry, that shouldn't be like that. I'm going to just fix this before I get too far here. It should be iron nitrate, and let's make it iron 3 for the sake of this example. So the iron was iron 3, so when it combines with the chlorine, it'll be chlorine 3, like that. And then the calcium will combine with the nitrate. Calcium is 2 plus, so when it combines with NO3, 1 minus, so 2 plus 1 minus. So this will become 2, and this is just 1. So that's that. Now again, balancing. 2 chlorines and 3 chlorines, so I got to get those to a common number, so I'll put a 2 on this guy to get up to 6, and a 3 on this guy to get up to 6. So that means I need 3 calciums, and that means I need 2 of these iron, or 2 6 nitrates for my 6 nitrates. And that gets us all balanced up there. But again, the main point here is that the metal was with the nitrate, iron was with the nitrate, now iron's with the chlorine, and calcium was with the chlorine, so now calcium is with the nitrate. They switch partners. That's a double displacement reaction. What does this look like in real life? Well, one example of a common double displacement reaction that we're going to observe is the formation of a precipitate. So imagine that you have something like, let's say you're going to do lead nitrate. We'll make it lead 4 nitrate for the sake of whatever. And you're going to react it with potassium iodide. When we switch, so these are both going to be aqueous, or dissolved in solution. That's a 4. Just a second, I'm just going to erase it and make it a 4. Make it clear. 4, like that. Okay. So when we switch partners, we would get KNO3, which would be a pretty unremarkable product. That is still soluble in water, so that would still be aqueous. And, oops, what did I do there? Double displacement reactions is where we are. Plus lead with the iodine. And I made it lead 4 here, right? This was a 4 plus, that's why it crossed over to get the 4. So if this is 4 plus and this is 1 minus, when I cross them over I got a 4 and a 1. This product is not soluble in water. It would form a solid. In fact, if you did this reaction, this is actually a bright yellow solid. So what you'd have here is you'd have a beaker of clear liquid and another beaker of clear liquid, and we'd pour them together. So maybe I pour this one into here or something like that. And what's going to happen is this just appears as a clear liquid, but this forms a solid. And what we would see then is that all of a sudden this solution would turn a bright yellow. That bright yellow is these tiny little solid particles that are sticking together that result from the double displacement reaction. One more example of a double displacement reaction is a special kind of double displacement reaction called a neutralization reaction. When we have an acid and a base and they react with each other, the hydrogen from the acid and the hydroxide from the base are available to form water. The other parts, the cation from the base and the anion from the acid, can then come together as a salt. So in this particular case, HCl plus LaOH, the H and the OH form H2O, or water, and the Li and Cl in this case would form an aqueous salt, or a salt that's dissolved in water. Here we can see that there's a liquid there's water formed. The acid and base properties that come from either having a higher than normal concentration of hydrogen or a higher than normal concentration of hydroxide for these two substances would cancel out, and the formation of the salt lithium chloride. Both lithium and chloride wouldn't really do much here. They'd both just actually hang out in solution. A trick with all of this, so the acid and base properties would disappear. If you did this, I guess it would be a little bit of a trick, because it would be like you took one clear liquid, poured it into another clear liquid, and if you just looked at the color, you wouldn't notice any difference. But if you're holding the beaker, what you would notice when all of this happened is that this reaction produces a lot of heat. So the main indicator that a chemical reaction is taking place in this particular instance is the heat that you would feel when you poured these two substances together. On top of that, you would probably also, if you were to test the pH or look at some other acid or base properties of the two acids and bases that you put together, you notice that the properties that are distinct for acids and bases would be gone, because these two have neutralized each other, which is why we call this a neutralization reaction. So a double displacement reaction occurs when the cation anion switch partners. In real life, we can see these reactions. For example, if we form an observable precipitate, if we have a solid that forms together when all these ions mix up. Or, for example, if some of the ions are H and OH and they come together to form water to produce heat and stop being acids and bases, or neutralize the acid and base properties.